Hi everyone, Sir Keji here. Good morning, good afternoon, or good evening, depending on what time you are watching this video. Right now, we are going to discuss descriptive statistics and its basic concepts. I'll share my screen first. Hold on. All right. So let's start off with our learning objectives for this class. For this discussion. First we want you to define descriptive statistics, and then we also want you to understand the basic concepts of descriptive statistics, as well as for you to describe the distribution of grouped and ungrouped data. So what is descriptive statistics? Descriptive statistics summarizes and organizes characteristics of a dataset. A dataset is a collection of responses or observations from a sample or entire population. Later on, we will differentiate sample and population. But how do we collect data? Because it's mentioned there that a dataset is a collection of responses. There are actually several types of data collection methods. We can collect data from primary sources or from secondary sources. For primary sources, we can either observe, we can interview respondents, we can also send out surveys or questionnaires. An observation can be participative or non-participative. For participative observation, you are going to participate yourself in an experiment or in an ongoing process, while non-participative is you just observe by far, or afar or remotely. For interviewing or for interviews, you can collect data either in a structured or unstructured way. In a structured interview, you have set up your interview in such a way that the limit of the answers of the interviewee is scoped within your subject, while unstructured is an open interview. So you allow your subject to answer whatever comes into their mind. While questionnaire can either be mailed or collective. Collective questionnaire are wherein questionnaires are sent out by clusters or by groups, while mailed questionnaire are just sent out randomly to different respondents. For secondary sources of data, this is done through documents analysis. So this can be found from historical records, from government publication, earlier researches or existing researches, census, articles, journals, personal records, client histories, bibliographies, and service records. So anything that analyzes documents or anything where you collect the data in a document is a secondary source. As mentioned, we're going to differentiate sample and population, by the way. Population is just the broader group of people to whom you intend to generalize the result of your study, while the sample is just a subset of population. Um, Practically speaking, when you do research, it's almost impossible to to collect data to the whole population. That's why sampling was made. So just a group of people from a population was extracted or was selected in order for the researchers or for the analysts to draw out conclusion to the population. Because if you're going to think of it, gathering data to the whole population is very timely. It takes a lot of time, money, and effort. So that's why that's why sampling was made. So in analogy, so that you can understand better what a sample and population means, think of it as a large ocean. So the ocean is basically the population, and then you are just going to collect several species of fish or marine life in an aquarium. So the aquarium is your sample, or the fishes within the aquarium is your sample, while the whole ocean is your population. Okay, so I hope you were able to distinguish the difference between the two. So let's dig into the concepts of descriptive statistics. Descriptive statistics generally concerns describing data, and we have main types of descriptive statistics. We have describing data through distribution, concerning the frequency of each responses or value. You also have the measures of central tendency, which concerns the average values of the responses, and the variability or dispersion, the measures of variability or dispersion, which concerns how spread out the responses or the values are. First off is describing data or descriptive statistics in measures of central tendency. I know that you have heard of this so many times. Even in high school, we have the mean, median, and mode. Mean is just simply the average value. The median is the term in the middle of the data set, while the mode is just the most popular or the most frequent value appearing in the data set. um, a data set can have no mode, or there are no values that are frequently occurring. We can also have one mode or unimodal. We can have two modes or bimodal, or more than two modes for multimodal. For us to understand what these measures are, this is just a recall, no, for mean, median, mode. Let's have an example with a data set below. By the way, this is ungrouped data. Ha? These are collected randomly and are not categorized into groups. So in order for us to get the mean of the, oops, sorry. In order for us to get the mean of these quiz scores, we just simply have to add up everything or every responses, 10 plus 11 plus 14 plus 13 and so on, plus 7, and then divided by the total number of observation, which is 14. And that way we can get the average value or the mean. And the mean score for this data set is 8.79. Next is for us to get the median term. The first step in getting the median term for ungrouped data is you arrange the data set first in descending or ascending order, and then you get the middle term. For observation that are, I mean, for number of observation that is even, like 2, 4, 6, 8, you can actually get the definite middle term for that one. For example, this one, 14. So 14 has no middle point, where the midpoint of 14 is, the midpoint of 14 is 6 point sorry. The midpoint of 14 is 6.5, and you can find 6.5 in this data set. If you're going to count this from 14, 1, 2, 3, 4, 5, 6. So it only stops here, right? On number 11. So what we're going to do is we divide 14 by 2, that is equal to 7, and then we're going to count 7 from left to right. So first, we're going to count 7 from the left side of the data set. 1, 2, 3, 4, 5, 6, 7. So the seventh term is 11. And then from the left side of the data set, 1, 2, 3, 4, 5, 6, 7. So that is 10. And now we have two middle terms, the 11 and 10. And after that, you're just going to get the average of the two values, 11 plus 10, that is 11 plus 10 divided by 2, that is equal to 10.5. Therefore, the median score of the data set is 10.5. And then lastly, for the mode, we just simply have to count the value that is frequently appearing, or frequently appearing in the data set. So we have 11 and 4. 11 appeared 3 times, same with 4. It also appeared 4 times. So our mode here will be 4 and 11. This means that the data set is bimodal, or it has two modes. Okay? We're done with describing data in measures of central tendency. So by the way, it is called as a central tendency because the measurement is with respect to the middle term or to the average value of the data set. Okay? Next is the measures of dispersion or the variability. The measures of variability gives us a sense of how spread out the responses or the response values are. And yeah, we have several measures for variability. We have the variance and the standard deviation. We also have the range. But before that, let us recall the quantiles or the concept of quantiles, because this is where the idea of interquartile range and range came from. Quantiles is, by the way, quantiles is also called as fractiles. Quantiles is the cutoff point for a certain fraction of a sample. And then it can be it has three subtypes, or it can be categorized into three. We have the quartile, which means the values that divide your data into quarters. So first quarter, second quarter, third quarter, and fourth quarter. And we also have the deciles. This sorts the data into 10 equal parts. And we also have the percentile. So it's a number where a certain percentage of scores fall below the number. So it's percentage in nature. And then these three actually have common relationships. Um, for example, the first quartile, that is the 25th percentile. The second quartile or the second quarter of the data set is just the fifth decile or the 50th percentile. And the third quartile is just simply the 75th percentile. And the fourth quartile or the last quarter of the data set is just the 10th decile or um the last decile, and it is also the 100th percentile. Sorry, this is not 50, but this is the 100th percentile. Okay, and we also have the relationship between percentile and decile. The 10th percentile is also called the first decile because the count of deciles are up to 10, and for percentiles it's generally 1 up to 100. And then let's go ahead and talk about range and interquartile range. It's one of the measures of variability or dispersion of data. The range is just the difference between the maximum value in the data set and the minimum value, while the interquartile range is the difference between the third quartile and the first quartile. So it's Q3 minus Q1. Let's have an example in order for us to understand what these means. So let's just have the same example before. For example, for the quiz scores of ungrouped data or the ungrouped data of the quiz scores below. In this data set, the maximum value or the maximum score is 14 and the minimum score is 3. Therefore, our range is equal to 14 minus 3, that is equal to 11. And then next is our interquartile range. Since since IQR or interquartile range is the difference between the Q3 and Q1, we need to get Q3 and Q1 first. In order for us to get Q3, the formula will be the total number of observation times 3/4, because 3/4 is the 75th percentile or 0.75% of the whole fraction, and it is the third quarter of the data set. So it's we have 14. The total number of observation is 14 times 3/4. That is 10.50 term. And then we're going to round off the value to the nearest whole number. So that will be 11th term. The 11th term of the data set is the third quarter or the start of the third quarter. And then if you're going to count it, by the way, before, again, for interquartile range, the first thing that you need to do is you arrange a data set in ascending order. So from 3, which is the lowest, until the largest value, which is 14. And then since our since our third quartile is the 11th term, we're going to count from the lowest until the 11th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore, our 11th term is 12, and it is also our third quartile. And then for our first quartile, since this is just 1/4 or the first quarter of the whole data set, so the formula here will be n, or the total number of observation, times 1/4. That is equal to 3.50 term or the fourth term. So you're going to count 4 times from the first point of the data set. So it's 3 here. So 1, 2, 3, 4. So quarter 1 here is, or the first quartile here is 4. So our Q3 here is 12. It's already given. And our Q1 here is 4. Therefore, our interquartile range, Q3 minus Q1, 12 minus 4, that is equal to 8. And then another measures of variability or dispersion are standard deviation and variance. The standard deviation is denoted by letter S if we're talking about the sample. And then there is a population symbol for standard deviation, and that is denoted as sigma, this symbol here. But we'll talk about population measures when we go to hypothesis testing. Let's just leave this at bay. Let's just talk about samples first. So standard deviation is the average amount of variability in your data set. It tells you on average how far each score lies from the mean. The larger the standard deviation, the more variable or the more dispersed the data set is. While the variance is the average of square deviations from the mean, and then variance reflects the degree of spread in the data set. The more spread the data, the larger the variance is in relation to the mean. So these are basically the same description. It's just that the standard deviation is the square root of the variance. So we have a different formula for the variance for ungrouped data and group data, while for standard deviation it's the same. You just get the square root of the variance and you'll get the standard deviation. We'll talk about this later when we go to um, describing data in frequency distribution, because F here and MI has different notation. So please take note of the formula. And then lastly, we have the coefficient of variation in the measures of variability. The coefficient of variation is relative to standard deviation, is a statistical measure of the dispersion of data points around the mean. So the standard deviation, it tells on average how far the score lies from the mean, while the coefficient of variation tells the dispersion of the data around the mean. So again, the standard deviation and the variance um, refers to how far the values, or how far each score or value lies from the mean, while coefficient of variation is around the mean. Okay, unlike the standard deviation that must be considered in the context of the mean of the data, the coefficient of variation provides a relatively simple and quick tool to compare different data set, because this is um, denoted by percentages if you're going to multiply this 100 by 100. So let's go ahead and talk about describing data or descriptive statistics in distribution or in frequency distribution. A data set is made up of distribution of values or scores, and then in tables or graphs, you can summarize the frequency of every possible value of variable in number of percentages. For the variable of gender in this example here, oops, sorry, erase. For the variable of gender, you list all the possible answers on the left column. So there are 3 answers for gender. It can either be male, female, or other. And then you count the number or percentage of responses for each answer and display it on the right-hand column. So the number of responses from male is 182, and then for female, it's 235, and then other answer 27. So you just tallied each responses from male and gender. So this is for ungrouped data. So there are no groupings, or there is no distinct groupings or classes within each gender. However, for group data, you can group numerical response values and add up the number of responses for each group. Let's say, for example, here, the library visits in the past year. If it belongs from 0 to 4 visits, the the percentage of this happening in the past year is 6%. And then the library visit of between 5 and 8, it happened 20% of the time. And then if you're going to look at this group data, you can infer that, or you can assume that the highest number of percentage of visit belongs to the group between 9 visits up to 12 visits in the library. Okay, so we have classes here. So we have class 04 visits, we have class 5 to 8 visits, and we also have class 17 onwards visit. And in this one, this is presented in percentages. but it is also, or it can be presented also by counts or by tally. And then these are the key concepts that you need to remember in coming up with a frequency distribution. So first is Fi, or the frequency. This is just the number of occurrences, or the tally, or the scores. And then we have the upper class limit, or the UCL. It's the highest value within the class. The lower class limit, or LCL, this is the lowest value within the class. The upper class boundary, the highest value within the class plus 0.5. So this is UCL plus 0.5. And then the lower class boundary is the lowest value within the class, or LCL, minus 0.5. And then the class mark is denoted by MI, the average value of the class limits. Class limits are UCL and LCL. If you get the average value of UCL and LCL, we can get the class mark of that particular class. And then we have the relative frequency distribution. It tells the proportion of the total number of observations associated with each category. And then we also have the cumulative frequency distribution, which is denoted by capital letter F. It is the sum of the first frequency and all frequencies below it in a frequency distribution. You must add a value with the next value, then add the sum with the next value again, and so on till the last class. The last cumulative frequency, please remember this, that the last cumulative frequency will be the total sum of all frequencies. And then we also have we also have different formula for group data, because in our previous example, we are talking about ungrouped data. The quiz scores there are ungrouped data. There are no defined categories or classes with those quiz scores. But if you're going to group now the data in a frequency distribution, the formula for the quartiles will now differ. For Q1, by the way, I'm only showing Q1 and Q3 because these are relevant in getting IQR, or the interquartile range, Q3 minus Q1. But for Q1, that is the lower class boundary of the quartile class, or the class where the quartile belonged, or the first quartile belonged, plus n, which is the total number of observation, divided by 4 times the cumulative frequency of the quartile class over the frequency of the quartile class times the class size. And then for the third quartile, that is LCB, or the lower class boundary of the quartile class, plus 3/4 uh, 3/4 times the total number of observation divided by the capital letter F, or the cumulative frequency of the quartile class, or the third quartile class, divided by the frequency of the third quartile class times the class size. And then for the mean also, it differed, because for ungrouped data, you just simply get the average. But for the mean, you are going to get the weighted average relative to its class mark, or MI. So the frequency times the class mark, which is MI here, divided by N, or the total number of observation. And then for the variance, it's the summation of the frequency, or Fi, times the class mark minus the average squared divided by N minus 1. Let's go ahead and have an example for us to make this a little comprehensive, or for us to make this comprehensive. Okay, let's go and create a distribution, or a frequency distribution table using Excel. But first, let's start creating an ungrouped tally of these scores. By the way, the raw data here are exam scores of EDA students. This is just experimental, so this is just randomized. So in order for us to create an ungrouped frequency distribution, we can make use of the function in Excel called the pivot table. So I'll show it to you. By using by the way, the pivot table is an automated tool in Excel that allows you to organize data sets, especially large data sets, into frequency distribution, or to any group that you like to, or you can create a distribution or a table using the pivot table in a quick manner. So you can actually find the pivot table in the insert button here. in Microsoft Excel. And then in order for us to insert a pivot table in this data set, first is you need to select all the data set first, from the heading, which is the score, until the whole data points, until here. And then after that, you click pivot table, and then let's just put the pivot table on the existing worksheet, and then click here on the location where you're going to place the pivot table, and then click the down arrow again, and then click OK. So you will see this field once you have created the pivot table, and then you also see the pivot table fields at the right side of the screen, or at the right side of your Microsoft Excel. And then in order for us to get an ungrouped frequency table, you need to drag down the scores into the rows, as well as the values into the scores into the values. However, this gets the sum of the scores, but we need the tally or the count. In order for us to summarize the values as count, not as sum, you need to right click here on this row, anywhere on this column, and then select summarize the values by, and then by count. So there. So this table now shows the tally. This is not yet, this is still tallied. I'll change this to tallied na lang ha. So there. Because before we group data, we need to tally first each score. So the score, if the score is 51, the count of it is just 1. So this means that there is only one student who scored 51 in the class. There are 2 students who scored 52. There is 1 student who scored 53, and so on and so forth. So this is what the tally distribution means. But we need to construct a frequency distribution table, and we have step in order for us to create the frequency distribution table. The first step is we get the total number of observation, the maximum and the minimum value, and the range. So I have enumerated the things here that we need to find. We need to get the n, or the number of observation, the maximum value, the minimum value, and the range. And remember that the formula of the range is just simply the maximum value minus the minimum value. So in order for us to get the number of observation, the formula in Excel for that one is equal to, or press in your keyboard, equals, and then type in count A, open parenthesis, and then select the data set here. Select all the data set, and then close parenthesis, and then press enter. So the number of observation here is 50. You can actually use count A, but if you wish to complicate your life, you can actually count this one by one. 1, 2, 3, 4, 5. Yeah, depends on you. Next is we need to get the maximum value, or the highest value within the data set. The formula in Excel for that one is equal to max, open parenthesis, and then select the data set. So the maximum value in this data set, or the highest score is 99. And then for the minimum value, that is equal to min, and then open parenthesis, and then just select the data set, and that is 51. So the lowest score is 51, and the highest score is 99. And then in order for us to get the range, that is 99 minus 51. So the range here is 48. And then we're going to get the number of classes, which is k, by using Sturge's rule. So this is the standard, or the most common practice being followed in constructing a frequency distribution table. So in order for us to get the number of classes using Sturge's rule, the formula will be 1 plus, or equal to 1 plus 3.3221 times the log of the number of observation, which is 50. And then, by the way, I forgot, we need to round up. Again, round up. Not round off, not round down, but round up. So we need to raise this value to the nearest, no, not nearest, but the higher whole number, or the nearest higher whole number. So if we round up 6.64, that will be equal to 7, right? Even if it's 6.1, 6.0 something, you always round it up to to the nearest integer. So 6.64 becomes a 7. And then in order for us to get the class size, the formula for that one is just the ratio of range and the classes, or the number of classes, r divided by k. Our r here is 48, and then our k here is 7. So 48 divided by 7, that is equal to 6.86. And again, we need to round this one up. Again, round up. We always round up here. So 6.86 rounded up is equal to 7. Okay, so now that we have um, the class size, we can actually construct the group data now. So we need to get the LCL first. No, we need to get the first class first. So the first class is the minimum value first, 51. And then this is our first class, second class, third class, oops, fourth class. No, you know what? Let's just use the pivot table. So let's not complicate ourselves. So in Excel, just click Insert and then click on Pivot Table, and then select the data range again, the scores, and then existing worksheet. Let's just paste it here and then click OK. And then in Pivot Table, you drag down the scores in rows, and then you drag down the scores in values. Same what we have done here in tallied scores. So the sum of scores will be summarized by counts. And then after that, the row labels must be in categorical form, or must be grouped by 7, because that is our class size. So here in row labels, in this column, right click and then select group. And then in this tab here, by change 10 to 7, because that is our class size. So if you're going to click OK, it will summarize the value in frequency distribution, or it will automatically group the values. Diba? Easy ra. But you can also tally it one by one. Just ensure that the size between each class is equal to 7, like this one, for example, 51 to 57. If you are going to count it, 51, 52, 53, 54, 55, 56, 57. So you have the class size is 7. So that's generally the idea. So this is now your frequency distribution table for this for the exam scores, or from this data set. Okay, so I hope you were able to follow through. And now let's go and proceed to the worksheet. And then let's just use the same raw data. So this is still exam scores. By the way, in this worksheet, we are going to find the interquartile range, the number of observation, the mean, the maximum value, minimum value, range, the first quartile, third quartile, the interquartile range, the variance, the standard deviation, and the coefficient of variation from ungrouped data and group data. And then we'll use the same raw data earlier in this one, the exam scores of EDA students for April 2022. And then what I added here is the column number, because I want you to visualize lang the quartile classes later on, so that it won't be very hard for you to, it won't be challenging for us to determine what area of the class it belonged to, the quartile or the quantiles. So number 1 to 3 until 50, yeah, it's counted as until 50. This is our raw data. In order for us to get the number of observation for ungrouped data, this is just simply count A and then select the raw data. This is equal to 50, or this is just the total number of the last number here, which is 50. And then the mean here for ungrouped data is just simply equal to average, and then select the data set. So the average value for ungrouped data is 75.22. And then for the maximum value, this is max, and then select the data set. And then for the minimum value, that's min, and then select the data set. I think we have done this in a previous sheet. No, no. The next is for the range, that is the maximum value minus the minimum value. And then now the thrilling part is to get the IQR. But in order for us to get the interquartile range, we need to get the Q1 and Q3 first. We know that Q1 is the 25th percentile, and 25th percentile is the 25% of the number of observation. So if we are going to get the 25% of 50, 0.50 times 0.25, or 50 times 0.25, that is equal to 12.5. But there is no 12.5 here in the data set, only 13. So we need to round off 12.5 to the nearest integer. So 12.5 becomes 13. So that, no, before that, again, for quartiles, you need to arrange the data set first in ascending order. So I'll just copy this one, huh? This is arranging the data set in ascending order. So there's a button there in Excel in the upper right. Click on sort and filter, and then select smallest to largest. Sorry. Sort smallest to largest. And then continue with the current selection lang. We don't want to expand the selection to the other parts of the part of the spreadsheet. And then click sort, and then it will sort out the data set in ascending order. So since our Q1 here is the 13th term, we need to find the number 13 here. And then we're going to um, refer to the value that belongs to the 13th term. So therefore, our 13th term here is 60 based on the ascending or the arranged data set. I mean, the arranged data. So our Q1 here, or 25th percentile, is equal to 60. And then for the 75th percentile, I mean the 75th percentile, or the Q3, that is equal to 50 times 0.75. So this is the 38th term. So we need to look for the 38th term that is equal to 91. So this is the 38th term, 91 on the arranged value. So there. And our interquartile range now will be 91 minus 60. That is equal to 31. Okay, I hope you were able to follow. And then for the variance, the formula for this one is the summation of x. The x here is the point on the raw data minus the average value squared divided by n minus 1. N here is the number of observation. Therefore, n minus 1 is 50 minus 1. That's 49. But we have a symbol here, summation. So we need to get the values of x minus the average value squared first, and then get the sum. So I have created here a different column, x minus the average value squared. The x here is the raw data, this one, minus the mean, which is 75.22, this one. There is a function in Excel where you can lock in a particular cell if you wish to move the formula to a different cell in Excel or in the spreadsheet. Because what happens if, for example, we just have to do it like this, and then we're going to paste it down, down. If you notice, the formula here also follows where you move the formula. You move it down, the formula also moved down. So in order for you to fix a certain position in Excel, fix the column and the row, press F4 once. So if you can see this dollar sign, it means that the row, or this one, number 3, is fixed, and the column J is fixed. So it's fixed on J3. Okay, but if you press F4 again, it will fix the row, which is number 3. So if you move your formula to different parts of Excel, it will fix the row, but not the column J. But if you press F4 again, it will fix the column now, and not the row. So if you move the formula to other parts of Excel or in the spreadsheet, the column will be fixed on J, but the row can be different. Okay, so you're going to fix 75.22 all throughout. So we pressed F4 once and then just copy and paste. Oh, by the way, we forgot that we need to square this one first. So there, we get the summation of x minus the average squared. We get the sum equal to, oops, sorry, equal to sum, and then open parenthesis and then select all the values here. So the sum here is 12,544.58, but the formula for variance is we need to divide the summation by n minus 1. N minus 1 is equals to 49. So this one here is divided by 49. And that is equal to 256.01. That is the variance. And the standard deviation is just the square root of this value. And in Excel, the formula for square root is equal to SQRT, open parenthesis, this one, the square root of the variance. And that is 16. That's the standard deviation of the ungrouped data. And the coefficient of variation, the formula for that one is the standard deviation divided by the mean, which is 75.22. So our coefficient of variation is 21.27%. So that's the degree of the dispersion of the data set, 21.27%. The higher the coefficient of variation is, the dispersed the data, the more dispersed the data is from the mean. Okay, so we're now done with ungrouped data. It's pretty straightforward. For ungrouped data, we have a different method for that one. So I hope you follow me step by step. For the number of observation, that is still the same, equal to 50. But for the mean, the formula for the mean here will be the summation of Fi, or the frequency, times the class mark divided by n. However, we haven't grouped this data yet. So our first step here is we need to create the distribution table first, which we have already created here, right? So these are the distribution, this one here. So we can just copy this one and then we can paste it here. Okay, so these are the Fi here. If you still remember, if you can still remember in our PowerPoint earlier, Fi here stands for the tally or the occurrences. LCL is the lower class limit. UCL is the upper class limit. MI is the class mark. Okay, and for the mean, we need to multiply the frequency Fi and the class mark. And in order for us to get the class mark, we need to get LCL and UCL first, because that's the average of the class limits. I mean, the class mark is the difference, I mean, the average of the class limit. So the LCL here, or the LCL here is 51, the lower class limit, 51, and then 58. We also have 65 for the third class, 72 for the fourth class, 79, 86, and 99. And then for our upper class limit, that is just simply 57, 64, 71, 78, 85, 92, and oops. No, this is not 99, but 93. And our upper class limit for the last class is 99. Our MI here is just simply the average of the LCL and the UCL. So that's 54. And you just copy the formula, the average of LCL and UCL. So we now have the MI, or the class mark for each class. And for the computation for the mean of the group data, we need to get the summation of the frequency times the class mark. So I have prepared here a column for the frequency times the class mark. So Fi times the class mark. So we need to copy the formula. So 8 times 54, that is equal to 432. 9 times 61, that is 549, and so on. And you need to get the sum of this value, whether it is sum, or you need to get the sum of Fi times Mi. So there. So that is equal to 3,771. But we need to divide this one first to n, or the total number of observations. So 3,771 divided by 50 that is equal to 75.42. So that is the mean for the group data. So if you notice, the mean for ungrouped data is 75.22, but it changed when we group the data now. The max value is still the same with the minimum value, and then same with the range. It's still the same for group data. But for Q1 and Q3, or for quartiles, we have a different story. It's a different formula. For Q1, the formula for that one will be the LCB, or the lower class boundary of the quartile class, plus n divided by 4 minus the f. Capital letter F is the cumulative frequency of the quartile class, divided by Fi, or the frequency of the quartile class, times the class size. Let's start with the Q1 class first. Hold on ha. Wait. Sorry about that. Let's continue. So yeah, in order for us to get the um, first quartile class, all we need to do first is we need to get the sum, or the n here, which is equal to 50. And then after that, we get the cumulative frequency. The cumulative frequency, again, is the summation of the um, frequencies from one class to another. So it's the summation, or the accumulation of values. So our first cumulative frequency for the first class, that is equal to 8. And then we add up the next frequency, which is 9, to the previous frequency, which is 8. Oops. So that becomes 9 plus 8. So this becomes 17. And next will be 17 plus 7. And then until it adds up until to the last class. And the definition of cumulative frequency distribution, you need to remember that the last class must have the total number of frequency. So the last class has 50 cumulative frequency, and it must be the same with the total number of frequency, or tallies. And then for the Q1 class, all we need to do is just simply multiply 0.25%, I mean 0.25, because this is the 25th percentile, the Q1, times the total number of observation, which is 50. So that is 12.5. So what we're going to do here now, basically 12.5, you need to locate in the cumulative frequency where 12.5 belong. Okay? So from the second class here is already 17. So it doesn't belong here on the second class. So it should belong from this class 8 until 17. So our Q1 class is this one. Okay? And then for our Q3 class, that is simply 0.75 times 50. That is equal to 38, or 37.5. And then we're going to locate where 37.5 lies in. So it can't lie here on this class from 86 to 92, because the cumulative frequency here is already 40. So it should belong in this class, 79 to 85. So our Q3 belongs here. So this is our Q3 class. So again, our Q1 class is 51 to 57, and then our Q3 class is 79 to 75. And then part of the formula is the LCB, or the lower class boundary. We have a formula for that one. It's just simply the LCL minus 0.5. So this will be our lower class boundary. The lower class boundary is the real boundary, or the real, not the limit, but the real boundary from one class to another. So 50.5 for the first class, 57.5 for the second class, and so on. And our formula here is the LCB of the Q class. Let's start with Q1 first, ha. So the LCB of the Q1 class is 50.5, right? And then plus n divided by 4. Our n here is 50 divided by 4, and then minus the capital letter F, or the cumulative frequency of the Q1 class, which is 8, right? And then divided by the small letter Fi of the Q class. So the Fi of the Q class, or the Q1 class, is 8. So there. And then we multiply this by the class size. The class size, if you can still remember, is equal to 7, right? The rounded up value for range divided by k, that is equal to 7. And then we press enter. So our Q1 here, wait. Yeah, our Q1 here is 54.4375. So that will be our Q1. Wait, let me check. Yeah, that's right. And then next for the Q3, basically the same formula, the LCB of the Q3 class, which is 78, and then plus, by the way, this is it, plus, yeah, 78.5 plus um 3 4 3 um 3 times 50 divided by 4, or 3/4, let's just 3/4 times 50 na lang. 3/4 times 50 minus the cumulative frequency of the Q3 class, the capital letter F, which is 30, and then divided by the frequency of the Q3 class, which is 2, and then times 7, which is the class size. So our Q3 here is 104.75. 104.75. So there. Yeah, 104.75. Or yeah, it rounded it rounded up to 104.8, but it's basically the same. And then for our IQR here, that will be 104.8, or 0.75, minus 54.43, that is equal to 50.3. I think there's something wrong with our formula. Wait. 65, 72, 79, 86, 93, 57, 64, 71. Wait, let me verify. Let me check first. Right, I have verified our computation. It's right. So as you can see, there's a difference in the computation for the interquartile range for ungrouped and ungrouped data. If you notice, the variability for IQR increased as we group up the data. And then our next computation will be the variance of the group data. The formula for that one, I think it was shown to you in our PowerPoint earlier. That is the summation of the Fi, or the frequency, or the tally, times the class mark Mi minus the average value squared over n minus 1. So n minus 1 here is 50 minus 1, that is 49. In order for us to have a comprehensive way in in performing this formula, we need to get mi minus barred x squared first. So we already have computed the mi here, which is 54. minus the average value or the barred x here, that is equal to 75.42. And then we are going to square this. By the way, we are going to press F4 on the average value because we're going to fix the formula. And then we're just going to copy and paste. So this is now mi minus the average value squared. This one here. And then after that, we're going to multiply this one to the tallied frequency, which is 8. So this will be this times the frequency. And then just copy the formula. So our sum here will be the numerator, the summation of f times mi minus barred x squared. And then to get the variance, we just simply divide this one by n minus 1, 50 minus 1, that is 49. So this now is our variance. If you notice, the variance of the ungrouped data is greater than the group data. This means that the group data is less dispersed or less spread out compared to the ungrouped data. And then after that, we just get the square root of the variance. Oops. Equal to square root of the variance, 246.82, and that will be our standard deviation, which is 15.71. Although the IQR or the interquartile range is spread out, it isn't true for variance and standard deviation because it becomes lesser. Again, our rule for variability, if the variance or the standard deviation or the coefficient of variation is larger or greater, the dispersion of the data is also greater, or the data is more spread out. And then our coefficient of variation is the standard deviation divided by the mean, which is 75.42, and that is 20.83%. So if you're going to interpret this calculation, the coefficient of variation for group data is 20.83, and that is lesser than the coefficient of variation for ungrouped data. Okay, so this wraps up our discussion for descriptive statistics. We were able to achieve our objectives. We were able to define descriptive statistics. We were able to understand the basic concepts of descriptive statistics and its types. And then we're also able to describe the distribution of group and ungrouped data. So I hope you learned something from me today, and you will remember what you have learned and understood what you have learned so that you can apply it in your engineering practice. Once again, this is Keji. Thank you so much for watching and have a wonderful day ahead. Bye for now.